Yeah, good to go. Three, two, one. We are live. Over to you, Tilotama ma'am. Tilotama ma'am, you are in mute.
Yeah. Thank you, sir. Good evening, everyone. I'm Tilotama Srinivasa. Welcome to webinar 12 of the Changemakers Winter Camp. During our earlier session today, we learned about what it takes to pitch your invention. Now, in the second session of the day, we are very excited to have two distinguished engineers from ISRO, Ms. Anuradha TK and Ms. Kriti Khatri, who will tell us all about product design and innovation in the space sector. My co-anchor today is Ms. Dhanya Shekhar. She's a fifth semester student of Information Science and Engineering in JSS Science and Technology, Mysore. She's an active member of the Google Developer Student Club as a graphic designer lead and is constantly on the lookout for opportunities to learn and communicate, such as public speaking, pitching ideas, and brainstorming with people from diverse backgrounds. So, may I now request Dhanya to introduce our distinguished speakers today, please? Dhanya?
Thank you, Tilotama ma'am. I'm very excited to introduce Anuradha ma'am and Kriti ma'am to all of you today. Ms. Anuradha TK is a retired director of the SATCOM program and a distinguished scientist with remarkable 37 years at ISRO. Her expertise spans system engineering, satellite realization, embedding system design, instrumentation, automation, interface buzzers, and protocol development. As the first woman project director at ISRO, she successfully led satellite launches, including GSAT-12, GSAT-10, GSAT-9, GSAT-17, and GSAT-18. She played a vital role in programs conducted by India, Russia, and France. Anuradha ma'am has been a key feature in satellite-based communication program, engaging in dialogues and various countries and ministries. She has represented ISRO and India in national and international forums, including prestigious events like Royal Exhibition Engineering Panel Discussion in London, along with NASA and ESA members in 2019. As a featured speaker in TEDx and BBC, she actively promotes STEM and space education in schools and colleges. In 2003, she received a gold medal awarded by Astronaut Society of India. In 2011, Suman Sharma Award by NDRF of IEI, the 2012 ASI ISRO Merit Award for realization of intelligence communication spacecraft. Anuradha ma'am continues to serve as an ambassador for women in STEP on multiple platforms, leaving an indelible mark in the field of space science. Now, if we speak about Ms. Kriti Khatri, she is a deputy director at InSpace, which is a part of the Department of Space, Government of India, and focus on promoting the space sector with a career since 2005. At the Space Center, SAC, ISRO, and she has contributed significantly to the system engineering, significant Gagan, and Kriti ma'am has involved in navigation hardware innovation, modulation schemes, signal switching, and onboard clock synchronization. In this Power Pack webinar, participants will be able to learn about the different components in satellite and their function. Along with that, many programs and opportunities for the students to be part of our country incredible space program. This is a truly unique opportunity for all of us, and I encourage you to pay full attention and use the chance to win the questions. Please type your questions in the Zoom or YouTube chat window. We will take up your questions at the end of the session. Before I start the session, I request all the participants to fill the attendance form sheet, which will be provided in the chat box of YouTube and Zoom. And the participants who fill out the form will receive the certificate at the end of the winter camp. Let me invite Tilotama ma'am to start the session. Tilottama ma'am, over to you.
Thank you. Farindra sir, could you make me co-host, please? Because I'm not able to unmute otherwise. All right. So thank you so much, Dhanya, and thank you for agreeing to talk to us today, Kriti ma'am and Anuradha ma'am. So everyone, before we start to design or innovate in a particular field, understanding it thoroughly is really important, right? Okay. So towards that end, may I request Anuradha ma'am to give us an introduction to the space sector itself, please? Over to you, ma'am.
Thank you, Tilottama. I welcome the students today on this wonderful afternoon. I will try to touch upon the basics of satellites, orbits, and applications because it's a huge topic. Let us try to touch upon and understand at least a glimpse of it. Let's try to do. First of all, definition of space itself. If you just see between the hands, that is also space, right? But technically speaking, in the various atmospheric spheres which have been defined, around 100 kilometers above the Earth's surface is called an imaginary line, Karman line, beyond which we call it as space, where satellites will be placed, right? But what is a satellite? We talk about satellites so freely. We know about natural satellites. We have our own beautiful moon.
Ma'am,
And of course,
sorry, you're not sharing your screen.
I shared already.
No, ma'am. We're not able to see it.
Let's-
If you can unshare and share.
Okay. Are you able to see?
Yes.
Yes, ma'am.
So I was trying to tell you about the space concepts. I hope we did not miss much. I was trying to tell you about what a satellite actually is. And we already know our natural satellites to various of our own planets. You can just see, I don't want to tell the numbers. Huge number of moons are there. They are the satellites, natural. But an artificial satellite about which we are talking, it is a human-made complex instrument. You know an instrument, you know a television, you know your microwave ovens. They're all instruments. A car is an instrument. Like that, satellite is also an instrument. I hope the display is okay.
Yes.
Yeah. Then, is it safe to put our satellites in the space? This instrument, how is it so special to put in the space? You must know that space is absolutely ferocious. Any instrument kept there has to withstand severe solar flares, which means a lot of matter which is coming and hitting it at atoms and particles, solar particles, and the geomagnetic storms because of that, which happen and which vary the ionic conditions around the Earth. And there are also cosmic radiations, a lot of particles which are coming not only from sun, away from various galaxies, supernovae, they are also coming and hitting. And there are Van Allen belts which are actually helping us around us. You know Van Allen belts? Magnetic spheres which are trapping those ions and helping us. But we can't put a satellite in that place because there are so many ions there, charged particles are there. And extreme temperatures. Space is so cold, unimaginably cold. You can see the temperatures I have mentioned. And it is having vacuum. Vacuum means there is nothing called an absolute vacuum. The numbers are something like 10 to the power of minus 10 torr. You know what torr means? A torr is 1 by 760 of the atmospheric pressure. And I'm telling 10 to the power of minus 10 of that, right? Such small particle content there. And in order to go there, our instruments also have to withstand the launch vibrations, acoustics, the vibrations go to something like 6 to 7 G. That is a kind of thing. What happens to these instruments? You can quickly see. If you have a lens there, an instrument which is trying to detect a star, it will get, totally blurred out because of the particles hitting it, or the materials can get, totally warped out. There can be short circuits, and the electronic circuits will misbehave. The memory in them will get corrupted. Processes don't go well. And the cold temperature can create some kind of process called cold welding. All the rotary joints will get welded up. So we have to take care of all these things. It's not easy just to say that we can put any instrument in the space. We need very special components called space graded components. So then why bother about these satellites? Why we have to go to space? It is risky. The success is uncertain. It is expensive. It is so arduous task, complex technologies, costly, and very special infrastructures are required. The huge acres together infrastructures have to be laid out. But there are a lot of large advantages. Like once you go up, you have a large coverage. So at one time you can see more, and you can give a uniform service everywhere. Today, whatever service you go, oh, sorry, I cannot cross over the ocean and give. It is mountainous area, sorry, I cannot lay the cables. Nothing like that. You get same service over Mumbai, Bangalore, Andaman Nicobar, or northeastern Himalayan lands everywhere. And the satellites are not affected by natural disasters. If there is a big cyclone, everything is getting thrown out, destroyed, but satellites are working there, the only means of communication. And the lack of atmosphere there, as I told, because it is vacuum, particles are not there, it is also an advantage for the scientists to have telescopes and clearly see far beyond and see and understand the universe. And satellites are easy to maintain because they have been built very robust and very long time. They'll be working. Because of all this today, satellites have become part and parcel of our lives. If you open the window of scientific aspirations, if you open the window of scientific aspirations, you will see that the basis is acquisition of knowledge, explorations, and innovations. But if you open the other window, because of these innovations, science, technology has brought in a lot of applications, businesses, and monetization. You can make money today. So either science or services today are strongly built on how much budget you have and what is the takers. You cannot just do without anybody to take. What are these applications other than, of course, the scientific explorations? We have major classification. Remote sensing. Remote sensing means without contact, you are able to observe something. That is remote sensing. Communication, interacting from one place to other place. And meteorology. So weather monitoring is another very important aspect from satellites, without which it cannot happen today. And then navigation. Who does not have GPS receivers in your phones today? Everybody, you have it. Navigation is by satellites. Similar to GPS, we have our own constellation called IRNSS or NAVIC. Okay. And they are not all watertight applications. You can mix and match remote sensing, communication, meteorology, communication, navigation, etc. So I'll just give some examples what have been done. It's very important that these applications are not brought in just to show off. These applications have a purpose in the mind. The purpose is very important. I would like to tell the students also. You want to do a project, it is not just that I want to do something. You must have a purpose in mind, why I am doing. The final thing should be there in your mind. Let me just finish our scientific explorations all of you will be interested in. I'll just try to put in one slide here. You see, we had our Chandrayaan-1, wherein first time we went beyond our 36,000 kilometers and we could reach another body in space, that is moon. Though we did not land, we went around, and President Abdul Kalam was there. He insisted that we should put a flag on the moon surface. And then there came scientists, all of us, we took it as a challenge, and innovative idea came up that we have to make one small experimental box called Moon Impact Probe. And from the orbit that was hard dropped on the moon's surface in the southern pole, and it helped for the first time. It was not a dumb box, it had experiments. For the first time, that Moon Impact Probe showed possible traces of water in the polar region. So that was a wonderful thing that happened with the Chandrayaan-1. Then we had Chandrayaan-2 and 3. All children, you would have observed it. Second time we were successful. So that is another big challenge, and which we had to do. It was full of innovations when you had to bring down from high velocity, when something is dropping, suddenly you have to make it into horizontal velocity and then slow it down and bring it down exactly where you want to sit. So first time we could not get the success, but we did not deter. Failures will never deter space scientists. So it will make us think more, act more, correct it, and analyze, and then make a successful thing. So Chandrayaan-3 was a success. Before Chandrayaan-3, we had Mars orbiter mission also. That was another wonderful thing. Every time you talk to Mars, our Mars orbiter mission, it takes 20 minutes for us to get back the information from the satellite. And how do we take automatic decisions? So a lot of autonomy was brought in, and a lot of such intelligence was built in, how it can configure itself, subjected to the environment. These things were a challenge and innovations which came in the Mars orbiter mission. And you also have seen our Aditya L1. We are going to spy on the sun today. Okay, so there the Lagrangian point between Earth and sun. You read about Lagrangian points. I will not explain today in this lecture. So at L1, Lagrangian point, this satellite will go into a hollow orbit. Means actually it's an orbit around nothing. Normally, there will be an orbit around Moon, orbit around Mars, etc. It will be an orbit around nothing. And it has to go all the way 1.5 million kilometers, sit there and work for 5 years. Already a lot of experiments are becoming successful. It will reach that point on January 6th. We are expecting it to happen. Notwithstanding that, we also had a laboratory in the sky, X-ray laboratory. It has detected, some nebula which was so many billion years, light years away, billion light years away. And it could detect very clearly, and it is giving very useful information about a lot of happening in the universe to the scientists all over the world. This was a very unique platform wherein the entire X-ray bandwidth, what is there, and the ultraviolet rays, it could detect and do such scientific things. And we are most awaiting for our human space program. Lot of experiments have been going on, like re-entry, recovery, pad abort test, and having that Vyomamitra humanoid. So many experiments are going on, and very soon we are going to get into that also. We have many more science programs. I'm just highlighting some of the major things. Just look at remote sensing. Remote sensing is, why is it important? The satellites can see more, as I told. See, if you're on the road, you can see the buildings around. If you just go over a building, you can little more area you can see. Go over the hill, you can see much more, right? So satellites which are in the sky around 600, 800, 900 kilometers above the Earth, they can see much more, bigger areas they can see. But they can see better than our eyes. Our eyes can see only VIBGYOR. So we are colorblind compared to the cameras we have made and put on the satellites. Satellites can see the entire spectrum and give more information to us. We are like colorblind people to it. So they can see more, they can get more information, and their resolution is very, very high. It's not that I will go to the hill and I cannot see the small cow moving around. It's not like that. Just have a look at this. How the resolution means what is the minimum you can see. There are applications where you have to see in kilometers. For example, forests, oceans, you have to see large areas. And there are applications where you have to see very small things. You can see now we are able to see sub-meter resolution, less than 1 meter. We can see what is going on the earth. Okay. So this is the beauty of it. And whether you can see only in black and white, or you can take in more electromagnetic waves, colors. So that is also another aspect of it, right? So what are the applications? I will not read out all that. We are running, there are so many. I can take 3 sessions on this. Everything. You need food for daily, you need water, you need shelter, you need good place to live, and you need to monitor the weather, and you need to have protection from disasters that is happening around. You take anything, environment is going bad day by day, so we have to monitor snow, ice, glaciers, so many applications. There is no department in the government which does not use remote sensing data today. So you can read about it when you see the slide little more. Aram say you can see that one. I'm just giving glimpse of everything. If you take the communication is again, because it is high up in the sky, you can cover more area. So you can connect from one to another. How does it work? It acts like a mirror. Look at this satellite. Think that it is a mirror. I'm sending a beam of light, and that beam of light will reflect and come to some other area. That beam of light will carry information. So that is how the communication takes place from the satellites. In fact, you know Kepler's laws, most of your high school students. So if you know this formula, the orbital period and the time taken for the orbit, if you substitute these constants, you will note that 35,786 kilometers above equatorial plane, if you put an object, it will look as if it is tied to the rope. You can see that satellite is moving along with the earth. It also takes 24 hours. It is always there with you. So that is a principle of communication. So how are we using it? Communication today is ubiquitous. It is at a fingertip, whether you are having a voyage, or you are on some ocean, midst of the ocean, or you are on some trekking somewhere, you are there, or you are on the airplane, in-flight connectivity is there. Everywhere you need to be connected. So does that happen through wires? It cannot happen. So satellites are a must for such communication, connecting to every nook and corner, anything, anywhere, anytime you are connected. Today, the backbone of the business is all the commercial applications on with satellite and optical fiber cables, of course, on the ground. Both are in tandem, they are working. Even if I'm at Timbuktu today, I can draw my money from the ATM there, which is there near my house. How is it possible? On ATMs, you will see antenna, which is connecting to the satellite to that area, and then they communicate with the bank servers, and I get the money, the currency I need there, right? And there is a beautiful Digital India program for which our satellites are connecting every nook and corner, northeastern area, Andaman, Nicobar. All these islands are connected. And today we want to bring in the digital connectivity to every nook and corner. That is the aspect of it. And there are many applications, social applications, like bringing education and health to the doorstep of everybody. Telemedicine and teleeducation, disaster warnings. As I told, satellites are not affected by disaster. So you have a system at a particular place, send a signal and you get help, etc. And if you're lost somewhere in the ocean, just press a button, fisherman, he will know that where they are, and he'll be saved, etc. So many such applications are there. Then you have the weather. So weather monitoring, we have all over India and over the oceans to a lot of data collection points. Satellite will collect the data, and not only that, they have observations from other satellites. How is the cloud, and what is the cloud containing? Enough water is there, whether cloud is moving away or is it going to be stationary? What is its velocity? All this information is collected by satellites and given to our National Information System for Climate, and we get the weather and climate information all the time, right? So And then we have the navigation. Navigation, of course, as I told, all of you have it on your hand. And here the orbits can be anything, multiple, very innovative thing. Here, ISRO has done a great innovation where a GPS kind of system is there, which has 24 to 30 satellites in the orbit, covering the entire globe. And managing so many satellites is expensive and very complicated. But navigation today has become very important as a national security. Recently, you might have seen where the war is going on, the aircrafts were drifted away because the GPS data was affected. So we should have our own navigation system as a national security. So India brought out a very novel system with just 7 satellites above India and 1,500 kilometers all around. And we are able to use every application, what you can do on GPS, you can do with navigation. So I have listed a lot of applications. It is not just to show where to go and where is that place, location finding. Wherever precise timing is required, the heart of navigation is atomic clock. It is giving you the information about precise time, and you can use it in hundreds of applications all around, including power grid synchronization, okay, and mapping of large areas. So many such advantages are there having this system. And then, as I told, there are multiple applications where you can club all these things. For example, you take our defense. Defense needs to have remote sensing. From the distance, it has to see which area, what it is. It has to have communication facility to the soldiers who are there nearby, whether they are on land, ocean, or air. They need to have the information. They need to have the weather information, and they need navigation data also. It's a combined application. These are the applications innovatively brought out by ISRO and many private companies who have worked and they have brought out. I also look forward that you utilize this kind of data and bring out some applications too, and including some social help, like for farmers or fishermen, you need to have navigation. And if you're lost, you give a signal communication, and then the help will come and rescue them. And then they will tell this is the international boundary, don't cross. These kind of safety features. And for farmers, the diseases are spreading, how fast they are spreading, all information is passed on to them. So all these applications are made into village resource centers. And disaster management is something very, very essential in the country. Today, because of satellite data, management is very effective. Many times the losses are inevitable, but managing the losses is very important, because you may have a lot of help, maybe going to the wrong place. You have to go to exactly where maximum destruction has happened. And these kind of facilities are provided by the satellites in a big way, right? So what are these satellites? How are they made of? So much things I'm telling, it must be so complicated. No, let me just give you an analogy and make you understand how it is. Every satellite has 2 portions, very clearly defined. One is called the payload. Payload means the purpose for which it has been put. It is supposed to do remote sensing. It will have cameras on it. It is supposed to do communication. It will have transponders on it. It is supposed to do the navigation activity. Then it has to have precise timing, atomic clocks as the payload. And many scientific experiments can be part of it. For example, observations on the moon or Mars or X-ray observation. All those things are called payloads. But payloads cannot just go and work on their own. They need, for example, just the brain is enough to do everything, not enough, right, for human beings. We need rest of it, hand, leg, one structure, everything is required. So those portions which support the payload are called housekeeping. So in the housekeeping, first of all, you have a structure, just like our skeleton. And mechanisms means you need to move things. You move this, you move your hand, you move your neck, you move your legs, right? So all those movements are called mechanisms. These are other systems which have to be brought in. For example, our lunar rover, it is full of mechanisms, right? And then it has to have fuel in it. that is called propulsion system. Not difficult to understand, right? It must be having. Then it's an instrument. It should have power. There is nowhere to plug it in. So you must have solar panels, and solar panels which can be folded, opened by mechanisms. And then it should have batteries. When there is no sun, the batteries have to be supplementing. And then you must be sitting at one place and then doing attitude and orbit control. Means, for example, if it is a camera, it cannot be seeing there. It has to see where it is supposed to see, right? So that is the attitude control. And camera with satellite is supposed to work at some height, let us say 600 kilometers. It cannot go to 800 or 400. That is orbit control. So you have to maintain this for a remote sensing. For communication, in the 36,000 kilometer orbit, you have to be on a particular longitude. So these kind of actions are done automatically using the sensors and actuators. Sensors means like eyes, our touch, smell. Like that, we see stars, earth edges. We see the stars. We see where is the star and what is the magnetic field at that point of time. Based on that, satellite has to know where I am and how I have to control myself. That brain is attitude and orbit control system. And then it's no use if we cannot talk to the satellite, right? We have to tell what it has to do and what it did and tell us back the data. That is telemetry and telecommand, like our mouth and ears. So they have to be working. And as I already told, the temperatures are extraordinary because there is no atmosphere. When there is sun, it can get heated to 170, 200 degrees centigrade, our packages. On the other hand, when it is not seeing the sun, that side it will become so cold, -40, -50, -80, it can go. So we have to have a system so that just like when it is hot, you put air condition on. When it is cold, you put heaters on. On the satellite too, we have such automatic systems so that everything works in comfortable temperature range. Otherwise, our instruments will not work. Semiconductors cannot work in any range of temperatures, or the rotary joints cannot work. The adhesives cannot work. Resins cannot work at any temperature. So they have to be maintained at proper temperature. All these systems together make a satellite. So just see how we do, like a building block, to the structure. You can see the structure here, like a skeleton. To that, all the packages, what all I told, control systems, thermal systems, payloads, all these units are fixed on big plates and then brought and put together, integrated together. But every component, as I told, they are specially treated, radiation hardened. They should not get affected by radiation. They are called space grade components and materials, both mechanical and electronic components. They are all put together in the form of a satellite. And then what we do, we have to make sure that the satellite is working at extreme temperatures and in vacuum. We have a huge setup called thermo-vacuum chamber, into which you can see the satellite is being loaded inside chamber. It will be there for 3 weeks, 4 weeks, depending upon the mission. And temperature cycles are made. Sometimes it is sitting in the refrigerator. Sometimes it is being heated here on the grill, right? And make sure that all systems are working. And all along, we keep it in vacuum. We take out through pumps, take out all the air from it and create a vacuum inside and see how it is and make sure that our satellite is ready to do anything in the space, right? So, and then after the satellite, there are external components which have to be added. As I told, big solar panels and big antennas. It is a great challenge that we test these things because these are supposed to be hanging in 0G condition, not 0G, okay. 3% of gravity at 36,000 kilometers. So you know the formula, it is inversely proportional to the square of the distance, that kind of gravity. But here, if you try to, everything is designed for that condition. And if you try to do the same thing on Earth with 1G, everything will break. So you have to have special setup called 0G fixtures. So you have to, everything is so innovative in space. You cannot imagine, because we have to imagine ourselves, we are in space and work on it. For example, a huge antenna, it is being tested with a air bearing here. You can see there is an air bearing on that, 0G is activated to that. And finally, the fuel and oxidizers are connected to the satellite so that it can go further. Then it is not over. We have to see that our satellite works with the rocket vibrations and the acoustic effect it gives. Do you know that it can break a satellite? Nearly 6G, 7G kind of force will be acting on the satellite when it is getting launched axially. I'm just telling one axis. So when it is acting, everything can come out. Your screws, bolts, nuts, everything will come out. So there are special means of adding those things, and make sure that you put on machines to give similar condition like you are going in a rocket, and see that nothing breaks. So that is something very important test. And finally, we also do this what is known as the compact antenna test facility, where you have to make sure that your intended telemetry and telecommand, which are on RF signals, are really having the enough strength, enough sensitivity, enough directionality. Those things are all checked in this one. After making sure all of that, we bring it to the launch pad, fill the fuel, mate it with the rocket, and the rocket comes to the launch pad, all set ready. And then once the launch takes place, it is satellite will be left at a particular point by the rocket. But later on, satellite itself has to take itself further to the required position. So it makes several attempts by firing its own small motor, which is like a small rocket, which is attached to that. And there it will start its services once it reaches that point, right? So ISRO has been innovative from the concept. The concept was when Russia and US were having such a fierce competition about space race in the Cold War area, India said, I want to do the space activity, not to race with them. No. We set our own goal. That's why I said, any aim should have a purpose which is very acceptable for the environment. So we had to convince the policymakers, tell that we are going to bring the space technology to common man and make our country better and get the approval. And it's not easy to get the space technology on a platter by anybody. We had to do a lot of cooperations, coordinations, innovations, and we have brought in exotic kind of products like sensors, antennae, so many varieties of them, and payloads are fantastic. And our rocketry, today we have our own heavyweight rocket called Cryo Engine with Cryo Engine Mark III. And today we are poised to go even to take a man in the sense human being, it can be a woman too. And we have all streams, remote sensing, communication, navigation, scientific, meteorology, and we are contributing a lot, not only to the country, to the neighboring countries, and to the world, for the global scientific community also. Today, ISRO has taken India to such a platform that others are ready to come shake hand, and they are telling that collaborate with me, let us do it jointly. So that is the confidence today ISRO has because of these innovative steps. And a lot of indigenization that we brought in is something I may take 3 days to explain the whole thing to you. I'm just giving a glimpse. And as I told, we don't get deterred by failures, never. We are like Phoenix, we always come back. We have introspections, hard reviews, analysis. Don't give up if you fail anytime, and bounce back. That is the real spirit. Never say die. You have heard that song? Beautiful song. We are like that. We never sit idle that I lost. That doesn't happen. So this is a glimpse of what is space and satellite building, and what are the applications, right? Where all you can use it in general, but not in general, in specific for a big organization like ISRO. So I want you to listen to my young friend Kriti who will tell you a little more about where you can get more information, etc. And I also welcome, I hope I didn't overshoot my time, and I really welcome questions. Thank you.
Yeah.
Ma'am, we'll ask both of you questions at the end of the session. But thank you so much for the very insightful presentation. I think, ma'am, if Kriti ma'am, if you could,
Yes.
start your presentation, I think we'll take the questions from the audience.
Yeah, so I hope my presentation is visible.
Yes, ma'am.
Yeah, so I'm really thankful. So my work is very easy now because Anuradha ma'am has explained everything. So it's like what all satellites ma'am told. So you need to pick up those small opportunities and work on that. So I'll be sharing a few glimpses and few links from where you can get more information on that. So as we know, there are many initiatives by ISRO for bringing the STEM education, educating students about space. So there are these few programs through which they do it. So all this information is available on the ISRO website, www.isro.gov.in. So we have this Yuvika program. It is a Yuva Vigyani Karyakram, that is a young scientist program. It's a 2-week residential program, and students from all over the country, from all over India are selected. The selection is done, and they stay at different centers of ISRO, and there is lab visits are there, some DIV kits are there, some lectures are there, and they get an opportunity to interact with ISRO scientists. Then we have student internships. These are for the college students. Apart from that, space tutors, a list of space tutors are available, and that help you get more information on the projects and the science experiments that can be done. ISRO STEM portal is there that helps you know more about the experiments that are there. Space on Wheels is a exhibition that we have. It's a bus that is having scaled down models and diagrams. If a student or a school wishes that the Space on Wheels visit, so they need to write to the administration, ISRO, and then accordingly ISRO will be planning to send that Space on Wheels to that location. So there is Respond program, that is a sponsored research program. This is basically for the PhD students. School Bhuvan NCRT portal is there, in which in a very interactive way, children can learn about the natural resources of India. So on the map, they can know which state is rich in which resource. So that way, it helps in educating them. Unnati program is the Unispace Nano Satellite Assembly and Training program by ISRO. This is basically for the foreign nationals and foreign students. So this is, like ma'am told, we don't do work for ourselves, but we also educate people around us, for our neighboring countries, neighboring states also. So along with that, IIRS Dehradun is there, in which a lot of e-learning programs are there. You can see the videos of already programs that have occurred, as well as programs, small short-term term programs keep coming, and you can attend them. So organizations actively involved with students, it's a very small list that I have presented because I just came across these, but there is a wide list of people, list of associations, foundations that are really helping students get accustomed with STEM to increase their awareness and help them in these fields. So there is American Indian Foundation, Quest Alliance, Learning Link Foundation, Space Kid India Foundation, Space Kids India, the Martin Foundation, Dr. Abdul Kalam International Foundation, and Space Zone India, and the list goes on. Few recent examples of where the kids could, students could send some experiments into space was on June 27, 2023, where a high altitude balloon satellite was sent into space. A hybrid rocket, February 19, 2023, was launched from the coast of Tamil Nadu, and 150 femto satellites were launched in it. In February 10, 2023, AzadiSat-2 satellite was launched on SSLV-D2. So there were 75 small experiments by girl students from across India. On February 8, 2022, high altitude balloon satellite was launched by schools, the students of Bangalore. So all these satellites as well as the hybrid rocket were all built by students by when they were by providing them like training, online training or in-person training, giving them DIY kits to make those experiments and help them send it to the space. So how this learning can be done, can be through fun. In Anuradha ma'am's one of the slides, she told how the telescope is in space, is watching the nebula and everything. So students can start with small experiments, and then when this experiment is successful at the ground level, then keep like modifying it so that the same experiment can be used when it is sent to space. So we have water rocketry can be used to learn the basic principles of physics, engineering and aerodynamics. So as I told, small experiments, small instruments can be made, small sensors. Like if we can take an example of a rain gauge, like you want to measure the rainfall that is happening in your locality. So you can start by measuring it under a shower so that you can calibrate the instrument. Then you can place it outside your home when the rainfall is happening. Then you can calibrate it for the whole locality. Then you can calibrate or you can modify it, because when the satellite is doing remote sensing, it is not connected to the earth. It's like from like from thousands of kilometers away it is doing that sensing. So how that sensing the satellite is able to do, so accordingly you can keep modifying your instrument or a sensor, and then you can keep improving the design by flying it using balloon, drone, sounding rocket. And then when the instrument is ready, you can send that instrument to space. Balsa wood glider is a very good way in which you can one can learn the basics of flight principles and control. So nowadays a lot of data, remote sensing is being done as ma'am told, and there is a lot of data about our planet that is available online on Google Earth engine, and Java APIs are also available. If we can use this data to make some applications that are really useful for the farmers or to our community, so we can really make be helpful for them. So a lot of courses on NPTEL and YouTube are available that one can get in order to learn how the data can be used, can be made meaningful. For this, the data analytics thing, one does not need anything. One only needs an internet connection and he or she can start working. So how students can participate? So as we all know, through this program also by the Niti Aayog and all the organizers, so many programs, many online workshops are being organized from time to time. So once you get that knowledge, you can use that knowledge to build model rocketry. You can participate in CANSAT missions. You can participate in sounding rockets. You can make balloon satellites, pico satellites, femto satellites, or you can all make modules that for the already available data that is there on the Google Earth or other platforms. A few upcoming missions that I come to know, it's not limited to this, and the list goes on if you keep searching on it. So Space Zone India is having a Rumi mission 2024. It is a hybrid rocket which is going to carry 3 CubeSat satellites and 50 Pico satellites. And this Rumi it will be launched in 2024, and they are having selection process where kids can participate, and there is a selection criteria, so you can apply to them and then you can see. And I just want to give a warning that because if anything is going to space, don't think that you can just pay on money and you can participate. Many times people will be there who may in the name of ISRO will try to earn money, but it is, you can just see how you can participate, how you can make some instruments, small sensors, and give it to a balloon satellite or to these NGOs that really work hard. So I also came across some NASA Tech Rise challenge that is for students to fly Earth and space experiments, but I think this is only for the people of the kids for USA and not for others. But NASA keeps having many experiments, at the CANSAT experiment or some or the other experiments that is open for all over the world. So you can also participate in these experiments. So in the end, I would like to quote Winston S. Churchill that continuous effort not strength or intelligence, is the key to unlocking our potential. So this is the with the same intention, Anuradha ma'am also presented that as a phoenix, we keep emerging as and when we fall down or if we have any fault. So same is my request to all of you. You keep presenting and keep motivating yourself and keep putting effort. So yes, sky is the limit. You can gain anything. Thank you so much.
Thank you so much, ma'am. And yes, just exactly as you said, and as Anuradha ma'am said, the thing about constantly of persevering. I mean, perseverance is then the biggest uh, thing when it comes to designing anything at all or solving problems. So thanks a lot. We have a lot of questions, so I will ask a few, and the way we're going to do it is I need help from either Funny sir or
Yeah, ma'am.
Nitish. Yeah.
Yeah.
So sir, what I will do is I will mention whose question I'm going to ask. So if you can
Definitely,
unmute
ma'am.
them.
Yeah.
And then also I'm going to talk about whose question will be asked next so that they can also unmute themselves eventually. Right. So Varshit, you had a question that's a little off topic, but it was cute. So maybe we can start with Varshit and then we will go to Anika. Right. So Varshit, had a question about being an astronaut, and Anika had a question about how to make, about satellites. So
Varshit Nagila.
yeah, can you unmute yourself, Varshit? And maybe turn on your video as well, please.
He's not responding.
Okay. Anika?
Anika, please unmute and speak now.
Okay, yes, good evening, ma'am. My question was that how we can make satellite cheaper and what are the major challenges faced by the scientists while making it?
Yes, dear. Can I take the question? Making a satellite is as I explained, it has many parts, and it is very essential that we make these mechanical and electronic systems. And when we do that, each system has to withstand the space conditions. That is very important. And when we build the satellite, we also have to plan how we are going to put it in the orbit, which rocket is going to take our satellite. And that is another design factor, how we start designing. Of course, satellite is thought of first with a purpose, right? What for we are going to make a satellite. First, we did Aryabhata just because we wanted to put something in the orbit. We wanted to know how all our mainframe systems will work. And along with some small experiment, we had put it. So second onwards, you cannot keep on doing just for fun, right? Or you have to keep learning and you must be having a purpose to it. So what is that purpose? You should be very clear. For example, even if you put a camera, for what I'm putting, is it for ocean monitoring or is it for forest monitoring, or I have to see the enemy line, the boundary between the two countries I have to see. We have to be very clear based on the specifications. We have to start making every system. Now, once we have a very clever camera, we need that the platform has to be very stable. It cannot be doing like this. What happens if you are moving your camera? You get a good picture. So those systems will start getting built with the robustness, right? So for the robustness, what is required? It has to be agile also. It has to be firm also. So these kind of qualities, we have to start building it. So everything starts from specification and which rocket I'm going to use. Is it suitable for my entire satellite? Satellite weight will come something. Let us say it came 3,000 kgs. Can I put it on a small rocket? I cannot put it. So I have to go to some other rocket. Is it viable? Then the political questions will come. Can we take this particular satellite outside the country or not? So all these factors is planning of the satellite. So technically speaking, so we know every satellite has systems. These systems, we have to make it for the application of the payload. What payload needs, we have to support it. So in fact, every satellite becomes very unique. Very rare that two satellites are made really identical unless there are some constellations which are building. Every satellite is like every child, it needs specific attention. No two things will be same. For example, if you take communication satellites, one satellite has to render for a particular band, like say, for example, C band. Some satellites have to refer to a different part of the spectrum called KU band. The entire design will change. Power requirements will change. Thermal requirements will change. Mechanical requirements will change. So first, what we do as a system configuration, we have to write it down. What is required? Absolutely. Then how they are interfaced to one another. So that is how the whole satellite design will start.
Thank you, ma'am. Priyadarshini, you're up next.
Thank you, ma'am, for the opportunity. I'm Anit, ma'am. Am I audible?
Yeah, go ahead.
What are the cryogenic fuels, ma'am?
See, there are different kinds of fuels. We can have what are known as solid fuels or liquid fuels. So everything has got its own speciality. Solid fuels can give you a big, push to you at a given time, but you cannot maneuver them, right? Then liquid fuels cannot give as much push as solid, but you can maneuver. When I want, I can reduce. When I want, I can. And also, there is another important thing for a given amount of fuel, which can give maximum push, right? So in that, cryo engines are the highest. Cryo means basically, cryo technology refers to very low temperatures. In cryo engine, we use liquid oxygen and liquid hydrogen. Liquid oxygen will be somewhere around, minus 180 degrees centigrade, and liquid hydrogen will be at minus 250 degrees centigrade. And handling them at that temperature is a technology by itself. That is called a cryo engine. It's a highly complex motor using at very low temperatures, unimaginably low. I'm telling negative minus 180, minus 250. At that point of you have to have, and you have to have a clear control of these liquids to go into the engine. They are called cryo engines, but they are the most efficient engines today, right? So they are cryo engines. We have it in our big rocket called GSLV Mark III, LVM-3 we call it, no? And also for the human space, we will use it.
Thank you, ma'am. Sujay?
Yes,
Sujay?
ma'am.
Thank you, ma'am.
Ma'am, so I had a question that in the recent Chandrayaan mission, it was stated that the Chandrayaan was not able to sustain on the moon because of the cold temperatures there, and we did not have the systems for it. It makes sense that the battery cannot last in cold, but the circuits, they said that because it expands and contracts, the solder joints sometimes break, and that's why it doesn't work. If that is fixed, if that problem is fixed, will we be able to sustain the equipments in moon for longer? Is that the only problem there?
It's not the only problem. See, it's not just because of contracted expansion. Most of the electronics will have semiconductors in them, right? The physics of those semiconductors themselves will undergo a permanent change. In mechanical parts, as I told, in the very cold temperatures, unless they're kept at proper temperature, they will lose their properties. Metal, whatever you have used, or any material you have used, it will lose its property. And the propulsions, you have to keep it in a particular state, liquid state, otherwise they will solidify. There are many problems when you go to very low temperatures. But can we not solve it? We can solve. Instead of solving everything, we need to have a powerful battery, powerful power generation, right? So it has been done by other countries. So radiothermal generations. So those things can be used and can be done. we are just initiating on that. It is a big task, and it means that we are handling with the nuclear power, right? So it needs a lot of safety issues and all that, and different kind of constructions and different kind of operations are required. We are yet to do that. We have to do, right? So first, our concentration in Chandrayaan-3 was how to land softly on another body. That was our aim. And the life of Chandrayaan-3 was also meant for 7 days as operational, and bonus if it comes anything else, right? And we have to test these systems when we don't have this battery, we have to test for those very low temperatures. And generating that low temperature is also a technology which we could not do that, right? So our target aim was soft landing and work for 7 days. All the planned activities were carried out, right? So that was the story behind it. It's not that we can't do. We can do. For example, our Baba Atomic Research Center will join hands with us. They have experience in handling RTGs, and they will tell us that we can do jointly, and we have been doing. We have been doing also, but a lot of local safety issues are all there. We have to take permits and then do those. We will do one by one step at a time, because if we try to jump too much, we'll fall too low. Right? Yeah.
Thank you, ma'am. I think Ishan has a interesting question, and it would be great if I think both of you, ma'am, Kriti ma'am, and you could maybe have a go at answering it, because I know both of you have lots of ideas on this. Please, Ishan.
Ma'am, my question is how to integrate space technology in our small scale project.
Beautiful. So, in fact, Kriti, shall I start? You can add
Yeah,
later.
ma'am. Sure, ma'am. You can start. Yeah.
This space technology has gone into many small projects. You must be aware, I can give you some examples offhand. The artificial legs, for example, everybody has heard of that light material, how it can be used. Or even dentures, very transparent dentures you can put in. So you can keep seeing the advertisements where our cricketer, very famous, I don't follow cricket, I'm sorry. He comes in advertisement and he puts that and nobody can see that. You know what that is? That is from space. What we do, that is transparent hard material which we can use over our antenna, so that all those particles I was telling, solar flare particles and all, they don't spoil our antenna. At the same time, antenna is transparent. It can give out information, RF signals. That is one example. Even contactless thermometers, they came from there. Or night vision from space technology. So many things, even special blankets, to keep you warm, they are from the space technology. And including some cure for cancer. It has come from the space technology, wherein an experiment was done on International Space Station, where some LED lights, how they were able to keep it, out of infecting the small biology experiment that was used on the ground to treat cancer. There are so many examples like that you can include for many projects. See, what is important is you have to keep observing what are the things, and you have to keep your mind open, and then you see many applications. Many of the things what have happened, are accidental inventions, as you are aware. You know that even penicillin or the X-ray machine, they were all accidental discoveries that happened. They were not really doing it for that. Something else happened, right? So even your 3M pads, somebody was trying to find strong adhesive. In the process, he found something which is not too strong, very light, but it became a successful product, right? So keep your mind open and you see many applications. So if something doesn't work, can it be used somewhere else? You have to see that, right? So many processes, many materials, they are all from the space technology. Today, what we are using, day-to-day life.
Okay, ma'am.
Kriti, you want to add?
Ma'am, when you speak, I'm very delighted to hear you. So yeah, so it's so ma'am has covered everything. Yes. So yeah, you can ask some other question. I'll add.
Thank you, ma'am.
Ma'am, we've kind of overshot the time. So, Shachi ma'am, and also Anuradha ma'am and Kriti ma'am, do we extend the session slightly, or what do you suggest?
I don't mind, but I know Kriti has a small daughter. It's up to
Yeah.
her.
But we can extend, yeah. No
Good.
issues.
Okay, so maybe we will take a couple of more questions.
Sure, sure.
Samir Raj, you had a question about dust particles and rays. Where's Samir?
Hello, mom. Can you hear me?
Yes, yes, Samir.
I'm a space freak and I got multiple questions to ask you.
Yeah,
And
but you can only
actually,
ask one, no? Right?
yeah, yeah. So, satellites have very vulnerable things around them, the environment, and they actually kind of vulnerable to small dust particles and at very high velocities. They move at a very high velocities, which damage the satellites, and also cosmic rays also present. So the space rocks are moving everywhere at the every time. So how they actually kind of repair continue the space rescue mission. I mean repair missions on the satellite. They can't go anywhere every time.
Yes, Samir, you are very right. I think you are talking about two things. One is radiation, one is
Yeah.
debris,
Yeah.
space debris. Both the things you are talking about. Hey, what is that balloon going on my scene? I
I
didn't.
don't know, ma'am. I was
Yeah,
also
it's a
wondering.
filter.
Yeah. So these are the two things we have been discussing now. One is radiation. In order to, we know the radiation exists. Once you know the problem, half the problem is solved, right? So we have to make it radiation hardened. How do we do radiation hardening? There, let us take electronics. If you take electronics, radiation hardening process starts from manufacturing itself. So probably you are in which class now?
Eighth.
8th. So when you go to higher class, you will understand how semiconductors work. You need to have channels for the electrons to move from one area to other area. And if radiation happens, the channels collapse. So we have to, we have to make channels little wider, and how we package it. So for example, if somebody is throwing something at you, you can put a shield over you, right? Then it doesn't fall on you. So something similar to that packaging technology. So there are special materials. There are special materials you can use over the electronics packaging so that effect is reduced. And secondly, what we do is, wherever critical systems are there is nothing called one system fails and the satellite fails. Impossible. We'll have total redundancies on the satellite. As you rightly told, nobody can go and repair it. So the probability of both getting hit, both getting spoiled are there, but very, very low, right? And some of the times where the semiconductors misbehave, especially in computers, that the data gets corrupted. So we have many techniques for that. We do multiple voting. We take input from 3 systems and we do a majority voting logic. So many such systems are there. And mechanical systems. Mechanical systems have to be strong. Normally, when you say strong, you think of a brick wall, but you can't make it heavy like that, right? For radiation protection or any such mechanical impact on it. So you need to have very special innovative designs for that. You have some honeycomb structures to give the strength to it so that it is also light in it. And you have to coat it with aluminum layers, which are very light. So these are many things. For example, solar panels are totally exposed. Then what we do, we would have put extra solar cells on that. Even if some cells go, we still have enough power. And on the solar cells, there are protection covers for which you have to design it, put it, still make it not too heavy and things like that. And the cameras are there. Cameras are very well protected so that there will be a big hood for it so that nothing will come and directly hit it, or even any stray light should not enter. All those care has to be taken. Each and everything is very, very involved. We take one by one. What happens if this happens to this element, this element? So there is our reliability group which will look into each one, whether it has been protected against radiation, protected against any small particles hitting. The second question is about the debris. Debris is a menace today because I think small particles, they are millions in number today, man-made debris. And they are all moving at very high speeds, like 7 to 8 kilometers per second. So what is this one message with the velocity? You know, momentum. What is momentum? Mass into velocity is momentum. And Newton's law, what it says? When two bodies collide, momentums exchange. Right? So our satellite can get really affected by hitting of these particles because of their very huge velocity. Sometimes they can make a physical damage. Right? In fact, we lost a satellite most probably because of one of the hitting. One satellite called GSAT-6, a beautiful satellite we had made. And for no reason, within just then we have seen everything. Next half a minute, 30-second data we have, and the satellite is not responding, it's totally gone. It's a very rare occurrence. It can happen despite all the care you take. Right? And you know, in 2009, I think, one Russian spent satellite went and hit a US satellite. A lot of debris was generated. It can happen rarely, but space is big.
Ma'am, I think we don't have too much time left, and also I can't find the people who asked those questions. But one question for Kriti ma'am. Ajita wanted to know if the Yuvika program, for example, is only for CBSE students or who is it for?
I don't have that idea. I think we need to visit
Yuvika
the
is for
website.
Yuvika is for college students. So,
Ma'am, Yuvika is for school students from 9 to 12 standards. So these
9 to 12.
students, yeah, these students are handpicked from different like states, and then they are
From
taken
each
to.
state, 1-2 students will be handpicked, ma'am. And a first preference they will give to rural kids and for government school kids. And later, there will be a form that students need to fill. And forms, after scrutinizing the form, they will be shortlisted, ma'am.
Excellent. Actually, you know what, as part of this Niti Aayog program, you can contact ISRO for having specific programs also, because ISRO, in spite of having its own huge number of activities, they're trying their best to reach out and trying to do these things. And special wings are also made. And there's nothing wrong that there is some special space-related programs we have to do. Please help. So, Kriti can indicate whom to contact, and definitely it is possible they can help out, can do that.
Yeah, even if you want to visit, like if a batch of students want to visit one of the facility in ISRO, so they can write to the head of that department, whether it is a Space Application Center in Ahmedabad or it is in Bangalore. So you
They're
can
open.
approach them, and then a guided tour can be prepared for you. So according to the capacity of the student. And also when these tours are designed, when these permissions are given, so it's not like you approach for, you need to give ISRO time, because there are many critical projects that are going on, and there is a lot of permission for the students to enter the ISRO premises. So if you like approach 1 month in advance, so definitely you will be able to see the facilities, and even there interact with the senior scientists over there. And there is exhibition in almost all ISRO centers, so that is open for all. So you need not take any permission from anybody. You can just visit them.
That is an excellent thing, but very specifically through Niti Aayog, you can reach out for the wing which is interacting with the students to help out the Niti Aayog ATL projects. They will definitely. We have a capacity.
Yes, ma'am. Ma'am, the last question, very quick answer maybe, and I know you already answered it in advance. It's from Tara Joshi, and she wanted to know how ISRO's positioning system can be used in disaster management.
Yeah, Tara, is it?
Yeah, and I mean, with kind of the focus on projects that they can make, ma'am, if that's possible.
Yeah. See, actually, in my talk, I wanted to tell, then I thought there was no time. In fact, students have made what is known as HAMSAT. You're aware of ham systems.
Yeah.
So this is a very student project where you can make ham receivers or ham transmitters and then utilize for the disaster management, which is a very important task. And as many as there are, it is required because ham satellites are not over a particular region all the time. They are going around and they may be available, they may not be available. As many as they are there, it is very useful. That is one good thing. Students did one HAMSAT, in fact, once along with ISRO. Now we don't have a HAMSAT. But of course, we have our regular disaster management, different programs are there, big satellites and all that. But these HAMSATs are excellent. So anybody from home with the ham machines, they can give information to those HAMSATs and HAMSATs will send to all the centers. That is one wonderful thing you can do that.
Okay, though we would like to ask you lots of questions, and I know there are still over 15 raised hands, but unfortunately, we will kind of have to stop now. Preeti ma'am and Anuradha ma'am, thank you so much for taking the time to talk to us. We learned a lot. It was just amazing, and I think all of us are very excited about. I know even though there isn't that much that we can do as individuals, but I think we're still very excited about looking at what projects we can put together in this field. So thank you so much, ma'am. And thank you. And everyone, our next session is tomorrow at 4 o'clock, where we are going to be talking again to an amazing person about how to design low cost tinkering kits. Yeah. So do join us tomorrow at 4. Okay. Thank you so much.
Thank you so
Thank
much.
you, ma'am.
Bye bye.
By this, we'll end today's session. Meet you all tomorrow, students.